Hello, my name is Lynn with Southern Studweld, and today I want to show you our CNC stud welding system. Before I get started with the system itself, I'd like to tell you a little bit about Southern Studweld and the services we provide. Southern Studweld is a full-service stud welding provider. We distribute stud welding systems and equipment, accessories, and we manufacture weld studs here at our manufacturing plant here in Irving, Texas. We have more than 20 years experience in the stud welding industry, and we provide services to our customer, building custom weld studs, and we try to provide solutions to difficult problems that our customers have. One example of that is the steel industry recently asked us to develop a system to where they could tag material coming out of a steel mill. What this does is a patented gun with this extension and a patented coil and a patented weld stud will be used to apply identification tags to raw steel coming out of a steel mill. And you can see we've developed this long extension to where the operator can apply the studs to this 2300 degree material, and it keeps him out of the high heat zone. So this is just one of the examples of a special product that we'll develop for our customers to try to meet their needs. In order to understand how our system works, I'd like to explain the process of stud welding. Stud welding is a comprehensive method of attaching a fastener to a workpiece. You have a specially designed fastener with a small timing tip and a flange. An electrical charge is stored in a bank of capacitors in the power supply, and upon a triggering function, the electrical charge is discharged through the weld stud and through the small timing tip. Now this will initiate an arc which will cause the metal around this area to become molten. At that point, spring pressure or pneumatic force is used to force the weld stud into the pool of molten metal. Now this process takes about 4 milliseconds, which is about 4/1000ths of a second. So it's very fast, so very little heat is produced with this process, and you have minimal reverse side markings. The big advantage to stud welding is the time it takes to do it. It replaces drilling and tapping in a lot of applications in just a fraction of the time. So the labor-saving, time-saving aspects of stud welding provides the cost benefits. Now this is our CNC stud welding system. This system automatically loads and welds fasteners over a 52 by 54 inch work envelope using this weld head. The system is also equipped with a pneumatic valve that allows you to automatically clamp work during this process. So what I'm going to do is run the system. I got a piece of steel clamped to the table surface here. The first thing you'll see is the automatic clamps will clamp down. The weld head will move into position. It's going to weld 4 studs in a square pattern, 1 inch apart. The weld head should move back to a park position to get us out of the way of our work area here, and we should see our clamps should unclamp at that point. Let me go ahead and run this part for you and show you how it works. I'm selecting the file I want to run from my PC over here. I'm going to go ahead and put on my safety glasses, hit the start button. You should be able to see the system in action. Now the system's ready for another part to be loaded, and it would repeat this process over and over until you tell it to stop. Now this system, Southern Studweld put this system together, and it's not a prototype system based, that was put together in some garage or something. This system's based on proven production equipment. The weld components are manufactured by Betterman, which is a world leader in the stud welding industry, and the motion system for this machine was built for us by Machine Automation, which is a leader in the CNC cutting systems market. They have over 550 systems in 21 countries around the world. So this machine is a heavy-duty industrial production type of machine. It's made to run in industrial environments, and it's made to perform like you just saw. And it lays down these fasteners at about 4 seconds per stud. Now we have our 4 fasteners that have been welded to the material, and I want to show you the strength of the weld. If the weld is satisfactory, either the stud or the material should break. The weld shouldn't break, so let's test it out here. You can see the stud broke, the flange is still welded to the material. So when properly done, the weld should be the very last thing to give. And there's no way I'm going to be able to break these welds off of this part. One of the aspects of this system that makes it really unique, it's very easy to operate. I've shut the machine down now, and I'm going to set it up for you from scratch. So the first thing I need to do is just walk around and back and turn the thing on. There's an on-off switch in the back here. And that applies power to our systems. Now, the next step is to find the home of the machine. So there's just a hotkey down here on the KDM, this keypad. You hit Find Home, and the machine will start to home out all of its 3 axes. You'll see the head move to the absolute home of the machine, which is on this corner of the table. And after it moves to this part of the table, the gantry is going to go through a squaring process that will make sure that the gantry is totally square with respect to the table. So now it's found its home position. Right now this is the 0, of your programming system. So what you would want to do is set the home of the part. What I mean by 0 is the X and the Y axis. So you just use these keys here to jog the head wherever you want to go, and I hit the Set Home hotkey. Now home has been set right here where the head is right now. So this is my new 0 position. The next thing you need to set is the tool lift of the machine. Now all the functions on this machine are accessed through this keypad here, and there's a menu that you can access by hitting the enter button, and you'll see different commands pop here in our little display. So I can move up and down through several pages of menu items, and whenever I want to get to a command that's on that page, I use my left or right arrow keys to move my cursor to the first letter of that command. Then I select enter. Now I have my tool lift is set at 2 inches. I'll set that to 1 inch by hit 1 point, enter. Now that sets my tool lift to 1 inch. Tool lift is the amount of distance that the head will move up when it's not doing the weld function. That's to ensure your weld head does not collide with any clamps or any parts of the parts that you're working on. So you set your tool lift, you got your home set. The next thing to do is set the surface of the part. Now this is telling the system where the top of the material that you're going to be welding on is. And that's real easy to do. I get to my main menu, I hit surface, which is a hotkey down here. Now, there's a lot of functions that are hotkeys, which are just simply a key that you push that does the common functions of this system. I turn a switch and put my weld head into a down position, then I use my jogging keys to lower the weld head until the stud just touches the surface of the workpiece. Okay, right there my stud is contacting the surface of the steel I'm going to be welding on, and I hit the surface hotkey one more time, and that raises the head to the tool lift position. Then I flip the switch to put the head back into the up position. So now I've got the home set, I've got the surface set, and you're ready to run a file. Really, the only other thing you need to do is load some studs into the hopper, which I'll show you in just a second. But right now, you're ready to go into production with this machine. That's all there is to setting it up. You don't have to have any special skills or training, and that's what one of the big benefits of this system is. Now this system uses a vibratory bowl to feed the studs into the weld head. So the only thing you have to do to get studs ready to be welded is just pour them into this hopper up here. So I'm just going to pour in the studs that we're going to be using on this product, and we're ready to go. The rest of the system is going to automatically load those studs into the feeding system and into the weld head as the machine's being used. Another great feature of this system, it's very easy to program. There's no special programming knowledge required. You don't have to know G codes. It's a simple text programming format. What you have is a delimiter that says start_plot. Then you type in your X coordinate, your Y coordinate, and then the command ST, which that commands the system to weld a stud at that X and Y coordinate. So what you have is a simple text file that you create with any PC. You save it in a text-only format with the .nc as the file name, at the file name .nc. So what you have is start plot, your X and Y coordinates with ST, and then end_plot underneath that. That's all there is to programming this system. The X and Y coordinates will determine the weld points on this system. Now, another great feature this system has is you don't have to have any PC hooked up to it to program it. We developed a standalone file management system where you can create, edit, delete programming files using just this KDM keypad. It's very easy to do. There's a limitation. You can only store 20 files with 21 weld points using the KDM keypad. But most jobs are going to have 4 to 5, 6 weld points on them, so that shouldn't really be a problem. So you can create, edit, delete files using just this keypad, and they're stored in flash RAM in the controller of the system. That's a non-volatile type of memory, so if you have a power loss or the machine gets unplugged, all your programs are still going to remain intact in the system. You also have the ability to store or transfer files that are stored in the system to a PC, or transfer files that are stored into PC into the system. So you have the ability